Okay. So AWS is a not just a place where we just dump our data or utilize endless services. AWS is a tool which can be used for the storage purpose, also for the computation of our data also, and for the highly provided security they will provide us also, and analytical tools. So analytical tools also. So uh, analytical tools here is a very important thing to understand, because we are using a cloud services that in a sense we are dealing with a decently high amount of data, and if a service we are using can also provide us analytical tools is very much advantage, because if we are dealing with a a huge amount of data in a physical server, or we are using it all by all ourselves, and we are trying to build the analytics all by ourselves, running the queries on the high amount of data is very tedious, high time taking process, and it will sometimes break the application also. So this will not just provide some servers or some data, it will provide us a full length. It will provide us a full length requirement, all the possible requirement for a cloud service, as in a storage, as in a computation, as in analyticals, and many more we will discuss further. Okay. Yeah. So global infrastructure. So if I am sitting here in Hyderabad and I'm working for a global company, say some US based company, I'm building a application for a US based company. I want the server to be US based. So I don't have to go and travel to US base, take a server there, do the configuration based on region, and build the application there. No, I can sit here in my, not even in the, I don't even have to be in the office. Maybe I can sit in my home, have a have a setup of my AWS console with proper credentials, can select the region where the client wants me to build the application. Say I can build a application server for USS, Pacific USA, or I don't know, maybe somewhere in Colombia. I don't know. Name the farthest place where I'm in now. I can still just change a region of it, and I can still build, but making sure AWS providing the access access there. That's the only thing we need. But we can still build something of that region here, sitting wherever we want. And there is one other advantage for this. For example, it's a rare condition. You assume I have a server here in Chennai. I have a small data center in a Chennai. So I have a center in, it's hypothetical, I have a data center in Chennai where it is very near from beach, or they have just built a data center years ago, and just the sea level rised, and there been a flood situation, and there was a physical damage or flood happened in my region. So I don't have to stop my application. There will be no downtime. I can simply change a region of it and utilize it from a simple other region. So first first foremost important feature AWS will provide is availability. You you name the region, they can provide region anywhere where there are services are available. We can use that in our place. So what we are talking about here is AWS will provide us a console where we can search the services. We can just search is as simple as searching a vegetable item on an app. As simple as that, you can just go to a AWS console which is fully set up. Just create an account. It's a five-step process. Just have a Gmail ID or something. Just it will ask you your PAN card details or credit card details. It will take a nominal amount just for the verification, and you can set up a free trial. It will be around like 4 5 step process. It is as simple as setting up a Facebook account, or I don't know, maybe a Instagram account. As simple. You can just go there, have a valid account, uh, just navigate to the five steps, provide your details, provide your card details, provide your PAN details, uh, provide your basic information like address, phone number, get them verified, and just maybe authenticate it from your mobile or Gmail. Those are the basic 5 steps, and you can create an account. Once you have created an account, make sure what region you are in. Ensure that the region you are selecting and performing the actions are the correct region where you want the server to be. For example, you can't build a DB service in maybe North America and use build some, I don't know, maybe EC2 in Hyderabad and expect it to be work normally. We can still do that. We can we it is also, I mean, I'm saying normally we don't do that. But we can still do that. We can just alter the outbound inbound rules. We can allow few permissions and we can still do that. But in the usual process, we'll make sure whatever we are creating, it's all in the correct regions. Make sure you are doing that. Make sure your first thing, you check once you created the AWS console is region, and the next thing is a IAM rules. So is your user correctly? Is are your permissions correctly are done? Is your root user is correctly configured? So ensure this validations like quick checklist, and you have a simple first free trial of AWS account. This free trial of account, anybody, you can just go today and create it, and just make sure you are not I mean, it's not possible, but just make sure by mistake or something you are not selecting some service which would cost you like, I don't know, some dollars by mistake. Don't do that. Just make sure you're selecting the free services, and there are a lot of free services that are provided by the AWS tool. Yeah, yeah, we can just quickly select the services. First thing, we can select a service that can compute. We can provide a service. For example, uh, in case of DB, we can utilize a Dynamo DB, for example. And for storage, we can use a S3 bucket. We can know all these about in the further, I'm giving a simple first example. We can create all these services in one click. Just select, click and configure, all in few steps. So for you, it may be still hard, or it is still lot of work. Maybe it's I don't know in your perspective, but I'll quickly go one step behind and help you understand how the old kind of servers or physical servers will work. So that way you will appreciate the cloud more, probably, right? Like how it is more beneficial, how it is solving lot of problems. That's a correct word. How, see, if you are able to understand what was the earlier thing, you will be appreciate what problems it is solving in the first place. So for example, you take a normally built process on premises application where we are not using a AWS services or cloud services, how you will do it. Okay, let's build it like on an overview. Okay, I can't, first thing, I can't take a single IP, single server. I'll keep a DB in it. I'll keep all my microservices in it. I'll keep what UI in it and build it. It will not, if you are building very small application, it will work. But if you are building a decent application which is used by decent number of people, decent traffic, it will not work because it can't, it's simply, it will, the storage is not enough or RAM is not enough, right? If you are having that much traffic, a single server can't handle that much traffic, right? It will always, it's as simple as, for example, you are having a normal laptop and you are trying to open 100 apps, you will just it will overload it and it will stuck, right? It is as simple as it. You can as simply understand that. So how, how you will usually build in a regular way is, you will have a server specially for database, you will have other servers for backend services. Okay, in that backend services also, you will still bifurcate. It is advantage and disadvantage of its own. We call it microservice architecture. So it may be little out of this cloud thing, but it will be helpful. Let's understand this. What is the microservice architecture is, rather than having a single application where you will have all the configurations, all the namings, and all the services, everything in a one place, you will build a nicely built architecture such a way that it is loosely coupled. So if you are building everything in one service is gone, everything is gone, right? It's all downtime, right? But if you are building something as in a microservice architecture, what you will have is, you will have a microservice where you will have a configurations. Configuration is usually nothing but user management. See, any application, you take it as something as in streaming, Netflix, you take Instagram, you take a simple what you say, what you use in your college, some student related app, everything will start with one simple microservice called user management. It can be named differently. So there will be some application police people will use, the user will be changed, it will be student, it will be a normal movie enthusiast, it will be simple social media influencer. The user name, what kind of user is using will change, but there will be always set of users, and we will always store the, at least we will store what are the users we are storing. So there will be always one thing called user management that we will have in one microservice, and we will have other service which is important called, we can name it differently, but it is usually naming, or we can configuration service, where what are all the important configurations we need in a throughout application, we'll note there. So for example, um, so for example, we are building an application where we are getting the data from some vendor. So for example, I'm um, I'm building some application. What will take? Okay, we'll build some application which is used for let's say overall our college management, we'll say. So we'll get a set of data, one set of data regarding buses, when are buses coming, when are buses leaving, what are the drivers, or all those data from different set of people, right? We will have a different department that is from one place, and we will have other place, for example, placements. So you can't expect somebody from, I don't know, professors or HODs to give a placement related data. You will get the data from separate people, set of people called placement cell. Same way, in a real time application also, you'll get the data from different set of people. So for example, you will get data from, so if you are building a Netflix, you will get all the data regarding the latest movies from one set of people. You will get the latest, so you will get the data from all the Indian movies from one source and all the US movies from other source, could be, right? So you will, what you will do, depending upon you are using usability, you will bifurcate your application into different parts. You will not keep everything in the same part. So you will create a microservice for a bus management. You will create a different microservice for the placement management. You will create a different service for the lecturer availability management, right? So you will create a different applications here, and you will interlink it, you are interlink it depending upon the needed. So for example, you are also have a other application for the user student management. So depending upon what is needed, for example, if a user, they will always not necessarily connected, right? If you want a user details, you will simply fetch from that application. So what is advantage of this bifurcation? Assume something went wrong or some bug happened in the bus management. I don't have to shut down all my college website and sit. Bus website, bus microservice will still be down, but then I can still access the lecturer department or placement department. The other things will run smoothly, right? See, that is how we will build a loosely coupled system. So though the other sections are maybe because of bug, or maybe that specific microservice had some damage or some vulnerability, the other service will still work. Okay, so this is about that middleware. The backend services I'm talking. Then you will have something called DB. So the data from all these services we will store in something called backend services. And backend services also, depending upon our usability, you will bifurcate into different databases there. Each microservice may have a different database, and each database, however, will have a different tables, right? That's like a quick overview of how we will organize application. If you want to build something, you will bifurcate everything and all. So now if I want to build this kind of architecture, this kind of system on a physical server, I want to have a multiple servers. I want to I want to I have to enable ports, IPs on different servers. I have to make sure all the services are up. I have to make installations on each and every setup. and I have to make sure the connections between each and every services are proper, all this. And I have to maintain all these three physical servers by myself, and I have to make sure all the RAM is up, everything is up, or data is, uh, for example, is the storage overloaded, or all I have to do. But in case of cloud, all this tedious process, you can still build this microservice architecture in a simple steps, in simple clicks, sitting on a same monitor, same place. You can just click that and create a different micro. Same thing. You can create all the, for each user, each requirement, each usage is the correct word. So though you are building something huge, depending upon the usage, you will always classify it into different chunks. So usages, for each usage you will build a different microservices, and you will also have a DB. You will have a different service for UI. You will have all those, and you can simply build that in a few clicks. So firstly, we will firstly we'll know about these major services AWS will provide. Along the flow, we will also know the few important services AWS will provide, how it will help us, and how we will create it. Okay. First is EC2. Okay, EC2 is like a first step, you can say. So you can create, EC2 is nothing but Elastic Compute Cloud. It is a virtual server, which, as simple as you can understand, as you can rent this server and utilize. You can, so instead of maybe um, buying uh, some assumable, we can say, data storage or RAM, you can do some calculations for sure. You can assume I need this much of course you have to do an initial calculation. You can assume this much RAM I need. This is my availability. This is my storage. You can create a EC2 server with simple clicks. You can have the inbound outbound rules carefully configured. What are all the IPs that are allowed inside our application, and what are all the other services we are able to access, and what are all the IPs we are allowing our application to use. So it's like a, you can simply say that we are renting a server, renting a place where we can run our application. We can simply put it in this way. Yeah, we discussed about the same thing. So it will give you a virtual server with, we have to, and the main advantage, as we discussed, is you pay as needed. If you are not using it at that point, after a certain point, you can just stop use. So how the billing process works is, there will be certain rules. It's like you have to pay this many dollars for this many requests or this many hours. So simply as you use the service, you can pay it. If you don't want that application to be up, or you no longer want to use the website, you can simply again just click on your server, just stop it, and the billing stops. This is not possible on the physical server. Though you are not using you are using your server, you are not using your server, is server up inside your physical server, is the server, your application broke, whatever it is. So uh, we talked about all building these microservices, having a DB service, UI service. Here we, in the real time, maybe we recently we faced, there will be a problem like my user will give me, or my vendor will give me a large set of data. I have to store it, utilize it, do some analytics, or store it and provide it to client simply. So if I'm doing that on my existing processes or services, it will it will add lot of load to my existing servers, or it will make my existing servers so slow. So usually, maybe what we'll do, we will configure another physical server, you will store there, you will access it through SFT protocols. You can build a protocol, do so though you are though you are though maybe on a UI, though you are uploading that file in a user portal, it will store in there in a specific server where you reserved specially to store the attachments or large set of data. But using EC3, using S3 bucket, it's all made more simple, and the more important, and it will also solve you the more important concern, security. So you can't, definitely can't store or deploy configuration. Okay, assume you are having a, if you are building a Java application, you will have something called YAML file. I think you know that how important it is. You will have all the application configuration in the YAML files, right? What are all the all the important maybe passwords you say, or maybe it need not be always password. If it can be a link of a vendor which you are trying to access, if you are providing that in the YAML file, it is still important, because it's our job to make it secured, right? It can, or it can be some application configurations, all those are very very secure data. So all those are very secure data. So you can't just trust on some open source applications, or some other services, and simply you can't trust some open source services, or open source services, or some microservices, some servers, and upload your YAML files. Or for example, if you are building some Angular or Node application, .env files to the open source services or services. So because they are very important, in that case specifically you will always rely on S3 buckets, because it will have very clear, very regulated permission, inbound outbound permission accesses. And user, you can configure what user of what region will be able to access that file till what particular time. You can be this specifically give the access, have the security. So majorly we can say one for security, next for storage. So this will allow us to store the large amount of data which without burdening our existing applications. So they see, they are very open and clear that it will not affect, it will be unlimited and very durable. It will not break our existing applications. So yeah, okay, you will store that data there, but how you will fetch that data? So you will so depending upon what so it will support most of the technologies. If you are building application in Python, it will allow it will support Python, Java, Node, Angular. It will support all major .NET. So basically AWS will support all the major technologies. Whatever technologies you are working on, you can simply write a certain set of a code and simply access, give the location of your location of your AWS S3 bucket, and if you are allowed, and you of course you have to do a correct permissions, correct settings, correct configurations, and you can fetch the data. So again the same thing, in the database you can create create a database. It will support, may be Postgres, MySQL, Oracle SQL server, anything. I mean, major of the database technologies we use, you can use any of those languages and create a database server. And yeah, major thing you are not worried here is, first one is pay. You can pay as you use, for the amount you are used. So at the end, database is the specific microservice where we are mostly worried about the data storage, how much of the data we are using storage, right? So here we don't have to, that's the advantage it is providing. You can pay as you use. And the second one is, is data backup. So you assume you are having a physical server. Now you want to, and you are having a physical DB server. You want to migrate it to a different server, okay? And the DB is very huge. So how you usually migrate? You will create a backup of this server, backup of the DB. You can simply use some commands. If you are using SQL, you can simply use some, of course, you can simply use some SQL commands, or you can use, so whatever Postgres, MySQL, Oracle, we are talking, these are query languages. So to use them, what we'll use, you'll use something, some tools called, for example, pgadmin, or you'll call something called DB hour. You will have multiple. So these are majorly used tools. So those are simply nothing but whatever the data we are having, you want to see it properly in a UI form. UI, it will provide you an interface. Okay. So if you want to migrate whatever the database I'm having from one server to a different server, what you have to do, you have to create a backup file for it first. It can be a normal CSV file or .SQL file. For a huge set of data, you will always prefer to create a .SQL file. And try creating that backup file for very huge data. It will take hours and hours. And try your luck. See, people used to do that way, but it will, so if we are working on some fast track project, if it is very important data, you have to just wait for the DB to just have a backup load and just sit there till it is done. Just hours and hours just for it to create a backup file, right? Then once you are creating the data file, you have to migrate it to a different file and then do a setup. You have to do all this. So this long tedious process can be very easily done using the AWS database. And the other thing is, of course, you in all the things in it can be a EC2 normal service or DB service. The one advantage here is we are not having a headache of maintaining the service. They will, it is not our problem. They will maintain us, and we are not paying something we are not using. Simple. We are paying what we are using. Yeah. The other thing is same backups. It is more easily done, and the other thing is patching and updates. So if we want to do, we don't. So if we are having a physical Postgres server, we have to worry about the upgradations, patching, checking the vulnerabilities. But in case if you are buying a DB server from AWS, we are not worried about that. They will do a regular patching services, regular updates, and auto scaling. We will talk about this in detail further. Okay. So basically, what we want to convey here is, so rather than we worrying about the maintenance or tedious things, we can simply focus more about our application and make it better, make better solutions rather than worrying about what is my storage, what is my maintenance, what is happening at the server, is a physical damage happening or somebody, I don't know, you always have to have both cyber security and physical security. See, somebody is coming and burning down my data center or my simple room in my office which has my server. I don't have to worry about that. I don't have to worry about the cyber security problem, which is a problem which is occurred from the technologies as online or a physical problem. AWS is taking care of all the headache of patches, backup, updates, security. So this will provide me more flexibility to provide a better solution, or I can focus on making my existing application efficient. Yeah. So we have some other servers also provided by AWS called Lambda. So this is also place where you are doing almost same thing as EC2, but you still have Lambda. Why? The main advantage of Lambda is it's more flexible for the user. You are not, so in physical server, you are paying even if it is running, not running, broke, whatever it is, you're always paying. In the EC2, you're paying it if it is running. But in the Lambda, you're paying as you use, right? You're using 1 hour, you're only paying for that 1 hour. So, you can think of a use case, some application where you need the application only for 3 hours a day. So you can take example of some application where I want to sell specific type of tickets, or maybe consider you are somebody, So Ed Sheeran decided to build an application where he's selling his concert tickets, and he will sell his concert tickets only between 5 o'clock to 6 o'clock, right? So for that, he don't have to have a physical server where he always run the application. No, he don't have to, or he don't have to have a EC2 keep his application always up and use it. No, he can use a Lambda where he is paying for that application only one when it is up, and also when it is up for that specific timing. So here we are we are providing the user better pricing, we can say, still maintaining the scalability and availability. So we are not still compromised on availability. You can still, it depends upon your usage. It is always, see, you can always make your Lambda up and use it always. You can still do that. So availability is not compromised. Scalability, no, Lambda will still provide the same scalability as EC2. So we will relearn scalability again. What is so? So if I am having a 3 TB of a database or storage in a database server or a normal server, I have a 3 TB of storage. Tomorrow I want to have a 5 GB. I don't have to add a physical server, or I'm not spoiling or creating a problem to my existing application. I'm still simply upcycling my existing storage within few clicks without interrupting any of my existing structure. It's a simple scaling process. So it is providing all this availability, scalability, security with added advantage of a pricing. Yeah, you can quickly see that here. So EC2 will, it's the same thing, but major advantage is billing and scaling. So here, yeah, we'll learn about scaling more. First set of physical server scaling, it's hard, right? You have to physically adding a server, you have to literally build a new server. You take a new server of higher storage, build there. Currently, if you are using 2 GB, 2 TB server, you have to literally change the server. Next place, we have something called manual scaling. Now, you assess you will assess the traffic of the website. You understand the storage is getting full, the RAM is getting slow, and what you do, you go there, manually select, do some configuration, and increase the storage of your application. So you are simply doing it manually without disturbing the existing project. Next thing, auto scaling. What you do here, you will simply set a threshold. For example, you can say that you can simply configure that when my storage is more than 75%, trigger the one more cluster of EC2. This you can do. This you can configure and simply forget about it, right? You, in a physical server, you always have to continuously monitor what's happening. If something goes wrong, you have to do an action at that point. Or in a manual configuration, you say monitor, do it, at least you can do it quickly. But in case of auto scaling, you can simply have that configuration and forget about it. You might be sleeping somewhere, or like maybe in a vacation, and your application will have a huge traffic, it will reach a threshold of 75%, but nothing goes wrong. A other cluster of a EC2 will trigger and it will simply balance out. Now we are learning of other thing called load balancer. So what is load balancer? It is again simple set of load balance, set of loading configurations we can make using simple steps by saying what amount of traffic goes to what server. You can simply configure it to make the servers balanced, to not break the existing flow, right? To be so, it's like navigating the traffic to a certain different server if it is reaching the threshold. These type of configurations you can do using a load balancer, right? So now, yeah, somewhere your application storage is high, your RAM is high, you don't have to worry. It will simply reach to the threshold, start triggering a new cluster, your storage is managed, your performance is managed, your every, app will run smoothly. And when the storage is back down again, and now you say my traffic reduced, my storage, my traffic reduced, maybe the number of people using now are decreased now. No, will I still pay the amount for the triggered next service? No. As the threshold decreases, as the traffic decreases, this next cluster will automatically shut down and I will keep using the existing server. This concept is called auto scaling, where you will do a configuration and you will do a configuration and system automatically handle the adversaries of storage performance. And there is other thing called scaling automatically. It's almost same with the traffic. This happens majorly with lambdas. So same way, if the traffic is high, it will automatically trigger the new cluster and it will handle the application. So yeah, no, we are repeatedly taking this word called monitoring, right? How we are monitoring? You will simply use again a Amazon service called CloudWatch. It is a simple. Again, you go to the search bar, search CloudWatch. You will configure your application details there. It will completely show it will very neatly graphically shows that what is my performance, what is my storage, what are the number of triggers happening in my application graphically at the every moment. So I can use that data to, if needed, take some immediate actions. Now, better my website, better make my application better, or I can collect all this data from maybe a month. I can understand the graph and understand that flow and take a decision that will enhance my architecture or use it correctly, and they take a decision such a way that it is more helpful for my use case. So you are helping 100 people using your application today. You can do it, you can take that data, do some analysis and help 200 people tomorrow. So as simple, we'll take a simple example which I think you are well aware of as SOS application, which is majorly built for women, right? Usual SOS applications, how they are, they will have some scanner or some app which everybody have to install. Once you have an emergency, you will hit the trigger, correct? Once you hit the trigger, what are the information stored in my DB? What place the incident happened, right? What place the incident happened? What person was in emergency? When was she in emergency or he is in emergency? And other basic details. So I will collect. So first thing what I'll do, first immediate help. What I'm doing when the trigger comes to me, I will be able to see the trigger in my application. Go help that person immediately. That's the immediate better help I'm doing to the person. Next, what is the next thing I'm doing? I'll store the data. I'll do some analytics. I'll do analytics of what simple, we'll consider a simple thing. First analytics, what you'll do, what are the places where the triggers are majorly coming from. I'll identify this. I can identify this simply, right? Because every time the trigger happens, I'll have a location of them, right? So it is simple for me to get where it is coming from. First one. Next, from what are the timings where the trigger is happening more frequently, right? Next thing, maybe I can do some simple analysis of, is it happening mainly on females, males, or other thing is depending upon my area. I can do some additional analysis. Is it happening mostly around maybe places where the students are majorly there, or maybe girls hostel are majorly there, or colleges are majorly there. I do these calculations. Now what I can do with that, first thing, I have helped somebody in need immediately. I did that already, right? Next thing what I'll do, I'll take this data, I'll do this analysis, everything. What I'll do, I know have all this data. I have identified those major areas where the issues are happening, 5 areas, and I will increase the maybe I can do a simple action of increasing the number of securities there. So right, I can, so I see practically, if some issues are happening, I see it's not practically possible. Okay, I'll keep the police everywhere, I'll keep the security everywhere, I can keep the camera everywhere, each and every mile, right? So hopefully if it is that secured, it's fine. But usually that is not possible economically, also practically economically, right? But now with the data I have what I have done, I have identified these areas. Now first I'll focus on these areas, I'll increase the security, I'll increase the number of cameras, and at least I will avoid the major problems at that time. Or maybe I will increase the security in that specific timings also, right? So I will, so with just the data I'm collecting from past few months, I'm able to make some structural changes in my use case and able to help more number of people or make my application effective. And slowly I can feed this to a AM model and do some predictive analysis, which will furthermore helpful to make my application better. Yeah. So these are all possible with analytics. And the other thing we were talking about is CloudWatch. First thing, CloudWatch helpful is to first maintain my application health. It will give me clear details of database, storage, performance. Depending upon that data, I can do changes accordingly. Other thing is logs. So um, logs, you consider two scenarios. One is when there one moment where there was some issue or some bug in my application. These logs will help me trace out what was the specific time when the error occurred, what was the exact function that was called when the error occurred. So these first basic details I can quickly understand, just figure out. See, if I can get the specific major incident of a method, my work is half done, right? With the logs, if I can simply get the method name, I can go there, check all my method details, or it will also give you a line, also line number also, everything, and I can fix that easily. Second thing, for example, somebody unauthenticatedly logged into my application. I'm not, maybe a cyber crime also, or it can be simply somebody have done some other actions without correct authentication. That will be clearly, very clearly logged in the CloudWatch. I can see what to, at what time that action happened, who took that action, when it was, what was the action he have done. I can clearly know that, and I can easily find out what was the problem there. And other major thing. So if we are trying to maintain logs of a very huge application, it is, it will, the storing the logs will become other, it's like storing one other database, right? It's very, it will become very huge. And how do you maintain? You will have to, maybe if you are having some text log or something, to for a issue happened today, you have to search, load the whole file, you have to search the whole file. But in the AWS, you don't have to worry about the storage of the logs, and it will very clearly help us with small feature like filtering, sorting. So so the law, so if you know the timings of that, or you know some keywords, you can simply search it, sort the logs, and identify the problem easily, and basically maintain the log very easily. Don't have to worry about maintaining, searching a very large file, or storing the large file. Other, okay. While we are on this, we will also know about few other things. Something called sending a notifications. So I same again. I don't have to monitor my application always. So to be frank, on an so no, even though there are applications, people who support the applications as such, so companies will hire specific people called application supporters. They will majorly do the task of monitoring the application. So just to monitor the application, in case of a huge application, companies have to hire lot of people. So lot of resources are wasted here. But in case of AWS, and see, human can not always, so you'll have a shift, they will make sure somebody is always there, everything is all there. They will make sure somebody is always monitoring the tool, they will make sure, but at the end, it's monitored by humans. Somebody might slip out 5 minutes or 10 minutes, right? But in case of AWS, what is advantage is you can configure the emails. you can configure the emails when some error happened or some downtime happened, so or so threshold of storage increased or some vulnerability happened, so you can configure email, and you can quickly get a mail of mail with the detailed details what happened at what time, a complete report, which will make our job lot more easier. You can also set up alarms. There's something called alarms. You can have them triggered on the same adversaries again. Okay. Okay. There is something called VPC. So again, no, I have EC2, I have Lambda, I still need I still need VPC. Why? Because I want complete control of my IP, complete control of my subnet, complete secured control of my application. I don't want to use the shared resource. It's like I don't want to have a shared office. I want a whole building for me. Everything runs there, happens there, is strictly controlled by me. I want that control. It can be it can be for the security, it can be for the flexibility, or it's just the client want the complete control of what's happening for them individually. In that case, we will use VPC. So it's the same, it will again provide same scalability, security, but the most specific advantage it is providing here is control. And other thing is, for example, we are providing some services. We want to provide it for both public facing and private facing. Okay. Uh, so you can't run all the IPs in public. What are the example of public facing website? You can somebody try and give a example of a website which is public facing. You can try it. You can try. You can think of any. Okay, I'll give a more clue and try give an example of a any government built public facing website. Huh? You can try and give example of a IRCTC. It's a public facing website. Simple. Or all the and all the and all the you can simply name every website which a common person can access. All the bank website, name all the bank website public facing, name all the government related website public facing, name all the, I don't know. You don't have to. You just have to be a citizen of that country, and you can access all the website of that country. As simple as that. All those are public facing websites, but for each website you will have something called private submit. Right, for example, I'll give an example of police. Right, I am building a website where I am tracking the criminal details. Okay, so it is highly secured. It is a private. I'll definitely build, make sure, and strictly regulate and create a private website. Correct, because it's highly confidential data. Um, I'll create a private subnet. I'll create a private website which only police people can access, nobody else. But now, what I have other requirement here. I want in the same usage, I want to allow common people to what you can file a crime, right? That how do I do? No, it's no. Built a I have built a website for crime noting, but as a common person, how should I report it? For that, for this, so for a usage such there will be something, there will be always private subnet and public subnet. So this public subnet is accessible literally with all the people in the country, or maybe if I'm building it for a state, all the people in that state, and everybody, every citizen of that state can access that, like freely open that, file a complaint there. But of course, again, you so you may be considering something as in a crime, it is still secured, right? Maybe you will still regulate it on basis of user. So for example, I'm filing a complaint. You maybe 10 of you also will file a complaint. You shouldn't allow such a way that since it is a public website, I'll show all the 5 crimes there and who all reported that crimes, right? People will fight among each other that how can you file a crime against me or something. So you have to respect their privacy, right? Or it will create a problem. So how, what you will do, you will do a role based access. You'll call something called role based access to avoid this. So as a person, as a user, I will create a role. I'll create a role with my username. I will file a complaint. You will all create with your usernames. You will file a complaint. So when I open the website, though it is public facing, I will see what I have done. You will all see what you have done, and there will be somebody called probably admin. That admin will be somebody from the police official, right? That person will see all of your file complaints. That's how it is made more secured. And see, we can go more and understand, like we will also bifurcate it, like to make easy for them. What you will do, you will you will bifurcate all the crimes or files happened in the Hyderabad in one way, all happened in maybe Mahbub Nagar in one way, one entity, we usually call it entity, or what happened in Kurnool in one entity. So usually the police person from Kurnool only can see the Kurnool crimes. Police person from the Hyderabad can see Hyderabad crimes. It will make their life more easy, or it is easily regulated. So so that's how this public and private facing concept works. And is since the topic came, I want to just give more details what happens in the real world based upon my knowledge. And other thing happens in the public and private sectors is, mm, we will, other scenario I want to highlight here is, for example, um, now I am having a web. We will still stick to this. This is, so what we have now is a app for or website for a citizen. We'll have a app or a website for a police. But you will also have something called pri- uh, private facing website for this police app also, where you will only have a limited data where a citizen, a normal person can read. He can't he can't file a complaint. He can't do anything. He can't do any updates or inserts, alterations. All he can do is just read. So what so what we will provide them is maybe some regulations, some rules, what are the issues are happening there. We'll have some small public facing website which only gets, we can say, only gets APIs, so that a person from though he is accessing that same kind of application, he is only getting that. What we are helping here, we are avoiding the cyber crimes. So you are avoiding accessing or doing some query or injecting some SQL vulnerabilities to the application, because you are simply reading it. You are not having a write, update, delete access. So that way, you will, that app will be more secured. So this what, so I just want to highlight that how things are handled between, if you want something for a citizen or for specific it can be police, traffic police, or somebody really employees working on a specific category to a citizen. And also how we'll have as only specific read app for something to avoid vulnerabilities. And see, this we can do. We don't have to create a complete new servers. In case of VPC, you can simply create a subnet of public facing and private facing and use it for your specific use case. మీరు వాడుతున్నారా? వచ్చింది. Okay. No, we are coming to the, we will quickly have a review. Though every service seem little bit same, we have a specific service or feature which will highlight that service. We can say there are lot other parameters to learn about. What I'm trying to say is in the basic understanding of it. EC2, it will quickly provide us a place to run our application. Easy easy to build, pay as you go. But Lambda, you will pay for only the time you use. VPC, it will provide us the more secured way. S3, it is like a storage and security. And EMR. Okay, now we have all different kind of services where we are running the application. Why do we need EMR? Nothing but Elastic Map Reduce. This is for mostly specific usage of big data. That is when we are dealing with a very huge data. Okay, maybe we'll come back. Okay, there we mostly covered all the basic microservices of AWS, and one small microservices I want to cover is nothing but we call it system parameters, where you can store the passwords majorly or very highly secured details there, and you can have a strict inbound outbound rules. So you can maybe say that I can use some encryption or decryption modes, encryption mode. We have base 64 which will encrypt your data, but we are not taking so at the end you can decrypt it with the simple. If you are able to crack the key of that encryption, you will still able to decode it. So we are trying to make it help and make it more secured using something called system parameters, which will have very highly secured inbound outbound rules, how we are able to access that locations, and using majorly all our usernames, passwords, very highly secured things there, and we are fetching it in our applications. Again, however, AWS will support all the major technologies. Whatever app you are using, you can so if that whatever website or IP you are using it from is in allowed in the AWS, you can simply specify the address of system parameter variable and use it easily. So before going this, since now we discussed the major services we are using in AWS, we will understand more about big data and how it is used in the how we are utilizing or how we are performing the actions of huge data or computations of huge data using the AWS. And one more service I want to highlight here is Elastic. AWS Elastic Beam Stack. So what is it is a service which will, we can say, almost provide a complete service for a application to run. It will include, see why I have tried to help us discuss the major services of AWS first is, if we directly go to big data or try to understand other things, just naming EC2 or some other services names, you will not be able to understand, we will not able to understand it fully, right? So now since we know what are all the services, what are all major things we are doing, what are the major concepts, we can use it now for the big data. So see, we have discussed what is load balancing, auto scaling, health monitoring. So all this which we can do separately also, of course it's depending upon requirement. This all in a package can be provided by something called Elastic Beanstalk. So you can simply configure this and it will provide us a place to run our application. So you can see in the diagram also, it will have all the scaling, load balancing required, all the major things required for the application, storage from EC3, S3, EC2 for the computation of our application. Everything is provided from the elastic beanstalk environment. All you have to do is maybe run your application there. So basic infrastructure setup is done using elastic beanstalk. So we got one more word called Docker. So if we discuss in the real time scenario, we will quickly understand what is Docker. For example, it's a major issue we see in the real time scenario where you will have real time structure we set up in a real time scenario where you will have your application set up in your dev environment. So when you are working on application, one simple setup level of setup you have is, you will of course have a local setup where you will have a code, make changes there. Once you have completed the changes, tested the changes, you will add that to a dev environment or a QA environment. Or you in a real world it is simply mentioned as a staging environment, correct? So it is the one step before the production. After that, you will have something called production, that is a real time, that is a place where the real time application is present. So, the major challenges we get is uh, major challenges we get is sometimes we will have a configurational issues. So if the configurations are, we are worried about the configurations that are different in the dev, different in the staging, different in the production, different in the local, that's the one challenge we will face. And the other thing is, sometimes there will be a scenario where maybe, I think, even you see that if you scroll to the Instagram, I think you will get those reels where tester will throw a ticket or error and developer will come back that it's working fine in my local, right? It's like a classic meme or joke, you say. So, or he will say it's working fine in my staging, why it is not working in my production. That's a classic. తర్వాత అవుతుంది. We'll discuss about Docker in one line and we'll take a break. We'll just quickly discuss about Docker and we'll take a break. So, the major problem of having having different configurations in the different architecture, or having some issue in local or staging and it's not able to replicate in broad, this can be solved using a Docker concept. So you can simply create a mirror of a production or staging using a Docker image. You can create something called Docker image. You can simply create an image of everything, and it will, in this case, you will not have a problem where it is working differently in your production and working differently in your staging. You're not able to understand. This kind of problem is not possible in Docker. There is a uniformity of configurations in all your servers you are using or all the architectures you are using. That is like a major use case of a Docker, and there are all other use cases of being it is lightweight, you can build the image of it quickly, launch it in the containers of AWS, all that. But I would think this is like a major advantage of Docker. We will know more about big data in some time. Sorry. Now, so as we discussed, cloud services, it will happen in a different models. One as infrastructure, other one as platform, other one as software. So, what as infrastructure? Infrastructure is empty home. Platform is maybe it's like home with some more facilities or furniture. And software we can say is like you can just go there and start living, or you can just simply start utilizing the home. It's already it's a home. It's like I'm trying to give you analogies to try understand better. So in infrastructure service, we have a EC2 instance. So that will help, that is a place we can run our service. But in platform service, we have something called, for example, elastic beanstalk. We just have known about it. It's like it will have a complete package. It will have easy to if you what you need as to build application start. We want some place to run our server, right? We have EC2. We want to do some analysis. We have analysis, you want to do some auto scaling, load balancing, we have that. So all the basic requirements for my servers that are already provided in the platform services in the form of elastic beam, for example. So software as a service, so software as a service is nothing but we are providing service, as in we are directly giving up our client the ready to use application. He don't have to bother about, do I have a server, do I have a server which is maintained auto scale. He don't have to worry about the background of it. It is like a simply he can start 10-15 minutes. He will we are directly giving a server for ready to use. So you can see the examples there. In case of the infrastructure outcome, we are providing the EC2. In case of platform, it is Elastic Beanstalk. In case of software as a service, we are providing a direct, as in a Gmail or Zoom. So by that I mean we are directly providing a website. So you can see the same here. In case of infrastructure, it is majorly the clients it is used by, it is provided to an IT administrator. In case of platform, we will provide it to the software developers, because now the software developer don't have to worry about the DevOps tools or how my application, where my application will be, how it will be bought to the end users. I don't have to worry about that. Software developer, what his work, he'll build UI, he'll build backend, he'll build DB, and he will directly deploy it in the backend services, and he can utilize that. And software as a tool is basically provided for the end user. We usually call them a layman or a normal public users. So small models, it's the same. We have public, private models. It's depending upon the requirement for the security, and we have hybrid model, both a private and public, that we can use depending upon the use case. Uh, Private clouds. So yeah, we have almost learned all these things based upon these parameters. Of course, it's highly available, cost effective, scalable, reliable, and accessed globally. So what? So the if you say why big data is more important is because of the data explosion. That is, for every click or every milliseconds, we are generating trillions and trillions amount of data, trillions amount, like users are using in the same way, are doing a trillions of actions. So for a normal application or a server to handle this is very difficult. So comes the big data. Yeah, as we discussed, this much of the volume to first place store itself is not possible for a traditional server, and perform analytics upon that or do changes upon that, compute that is very difficult for a traditional server. So here comes the big data. So major advantages or characteristics of big data, we can say, is volume. Of course, we discussed big data comes in the picture only where there is a huge volume and we don't want to compromise on the velocity and variety. So you see, for somebody who is using a less number of, who is working on the less number of data, a image and PDF may not make much difference, or a simple file or huge file may not make a difference. But for a huge application with lot number of users, the volume, type, and variety of data does make a difference very much. So, but in the big data, it supports all the formats of text, videos, and sensor data. Yeah. So as we earlier discussed, the inputs of a website are not always users. The inputs for the website can or mostly come from the electronic devices like sensors, cameras, thermal sensors. I don't know. We can have lot of ways where we can detect the data and get them. And no, as we discussed, upon this high amount of data, high variety of data, and we can still perform some analytics there, and get to and generate some analytics which would add value to our application, help our use case, help build our application betterly, and help build our use case betterly. Yeah, this is a quick life cycle of big data. So we will complete it in maybe next 5 minutes. Just want to highlight one small thing before continuing that. So once you start working in a real time company or real time projects, um, so for assume, I say I funnily used to feel working on a bank job is like little bit boring, or assume working on bank, or just going through about fixed deposits, or I don't know, just seeing all those things, terminologies is like boring for me or something, assume. And you join software, okay, and what happens, you will end up working for a bank website. And no, you have to know what are amendments, what are fixed deposits, what how funding works, or how the transactions happens between two things. So, or you it's not like a disadvantage, or you can also say that you always wanted to working on so like fascinating like maybe something related to NASA, or something so meaningful as working on a SOS application which will help vulnerable women in a vulnerable place. Or you can, you if you are sentimental or want to work on provide some analytics on something called Tirumala Tirupati Devasthanam. Or so this will give you opportunity to work on different domains. You will know and get familiar with the different domains, because everywhere we are using we have to we are, software is providing the services, may it is aerospace, may it be healthcare, may it be banking, may it be traffic regulations, may it be complete controlling of a managing of a huge buildings. So I'm just trying to think about all the applications I worked around or something, or um, may it be something related to funding, banking. And here two things I want to highlight is, first thing, mm, is we always have this thing in our minds, or it's like when maybe when I'm studying also, or I even sometimes have, what do I have to do with knowing or being aware of a formula of a speed, or knowing see, it's all there, right? We always think that, what is the need of knowing Pythagoras theorem? What is need of me to knowing speed formula? What is the need of me to know the harmonic mean formula? Or see, you don't have to by heart the formula. I'm not saying that, but we will think in the first place what are the use case of that knowing Pythagoras theorem or knowing the simple calculation of velocity. And then what happens, you when you really started working on some applications, for example you are doing some tracking mechanisms and you will get the input from the vendors or something, then what will you will you there might be requirement where you want to know the speed of a vehicle at each minute. Then you will all immersed in the harmonic knowing the harmonic means, knowing the speed of a vehicle, knowing the velocity of a vehicle. And then you will build a website for a architectural firm. They want to know like what kind, what range of beam will help them, or what length, what angle. Then you will be hugely merged on knowing what is right angle, what is Pythagoras theorem, how to calculate the length of this. So see, it all depends upon how you are utilizing that type of information. It is always useful. I'm not talking you have to, you can just quickly look upon that formula, but being aware of it is always useful to solve a lot of problems. And second thing I want to highlight here is, um, see, you will all, when you are working on some different domain, for example you choose a health sector, coming from a background of engineering, you will of course not have much details about it. So there will always somebody called SME who have worked and done some PhDs or MTechs in IITs, PhDs, working in providing you those details and solutions. But as a developer, you should be able to slowly understand what is the requirement of that domain, what is the healthcare sector need, what is the healthcare sector of what my application is contributing to is helping. So when somebody, maybe somebody as a SME may know a lot of about the domain, but he will not know about the technicalities, what is possibility, what is not possible. So I can understand and think about what is better solution provided the technologies I have in my hand, and slowly understand the domain. Yeah. So you will be lucky enough to work in some nice domain where you always feel fascinated about, and you will use uh, all your domain knowledge along with your technical knowledge to provide a better solutions. Now, coming back to the big data, so all we do here is, first, the major tools you are using here, Hadoop, Spark. So Hadoop is mostly used for the storage and Spark is for the fast processing. And Kafka, we use it for the streamlining of a data without having any disturbance in our stream. So for example, we are getting data continuously for every 5 seconds or every 1 second from a vendor. We can't have a downtime in our application and lose that data. If it is loose, it's not for forever. Sometimes we can ask and send them again, but we can't afford to lose that data. So something very effective as Kafka will provide us a solution such a way that we are not losing our data. We have something called queuing mechanism, bulking mechanism, where it will help us to get the data. First thing, we are not having a downtime in our application, but though there is some downtime in the vendor or our side, we are not losing data. Everything, we got everything covered. So the life cycle we can say is collection of data, storage of data, processing, analysis. Collection can be from anywhere. It can be from user, application, anywhere, and we can store. Store can be from as simple as any major DB, Postgres, SQL, or one the AWS provided DynamoDB and processing the data and doing some analysis. So it's like a representation of the data flow. So yeah, collection, we can do it from once we got the data, we will collect in the AWS S3 buckets, DynamoDB, or Amazon Knicks, or you can process it either in the AWS Lambda, KCL, or AWS Glue. That you can take the decision depending upon the amount of huge amount of data or your requirement, or what kind of analytics you want to build upon it. Next one is data processing. You can process it using EMR. Yeah, as we discussed, EMR is one of the major services that is provided by AWS. Keeping in mind of big data, we also have AWS Glue. So actually, if you say, it will all work together, big data work all together in the combination of EMR, Glue, everything, and analytics you can do with the QuickSight, Athena, or Redshift. So yeah, this is like a major examples that happen, that are using the big data, Netflix, Amazon, or bank things. Or what are the problems we are facing with without using big data? Are slowness, missing in the trends, nothing but losing the data, wrong prediction. So since we will miss the data, of course we will have wrong predictions, and that will not help our use case or our prediction models. So yeah, and running, so buying the huge set of servers, maintaining them, it's all very costly. You can do it with the help of AWS. With yeah, so now if you see, as we discussed, this all will so you can use a different set of services to help big data services, but this is one of the popularly used set of services to smoothly process our huge data. EMR, in combination of Glue, which moves and transforms data. So the major flow we are doing is collect, process, analyze. So this can be done with the different set of services. So here we are selecting EMR, Glue to process the data, Athena to store the data, QuickSight to visualize the data. So of course, the major purpose we are using is for EMR is for the very huge data sets. That's why we are calling it is one of the majorly used Amazon services for the big data. So how it works? It stores the data either in CS3 or HDFC, FS, or it spins the data. So the once the store data is collected, it has to be computed. That is done either in the use case of EMR, spins up the class. It spins up the several clusters of EC2. So EMR is nothing but several clusters of EC2 is nothing but EMR. So what it happens is, it's not just in case of big things of um, big data. You take a smaller example of Java. So if you are processing on something of a huge data, or you want to manage something parallelly, what we use, you will use a simple use case called multi-threading, where you will create a multiple threads, and all the threads will asynchronously run, which will better our performance very much. Same, like, you can, I'm trying to help you understand you better. So same, one or the other way, same thing is happening using in the combination of in the terminologies of server, using in the combination of EC2 and EMR. So So with a physical server, you will struggle. I can be sure with my experience that you can struggle to do analysis of a 5 TB of data or 10 dB of data. But using a EMR, you can process, analyze the data of petabytes of data very smoothly. Yeah, so more details on the same flow. We use glue services, ETL services to extract, transform our data, and Athena is used to the storage of data without setting up the EC3, S3. So QuickSight, we use it for the visualization of our dashboards. So just like a quick overshot, EC3 is used for store unprocessed data, Glue is used for prepared data for analysis, EMR is used to handle massive data, Athena is used to run SQL queries, and QuickSight is used for the making dashboards. So what we are doing in the starting, we are collecting the data, storing the data. Next thing what we are doing is we are processing the data, and next thing what we are doing is we are doing an analysis. So it's like you take any application, that's a major goal, right? You collect the data, compute it, and analysis, take some immediate action which help us our application or use case, or do take the data with the analysis, visualization, and provide it the future data. So same things we have discussed already, scalability, availability, security, all these are majorly advantages in the AWS. Thank you. పర్లేదు పర్లేదు ఫోన్ ఉందని వచ్చానంటే.
So thank you for all the participants and all the coordinators to joining us on this FDP and making the day one as successful. And thank you Apurva for giving us your precious time to give this session on the cloud computing and as well as the AWS services. Now I would like to invite Ms. Radhika ma'am, uh, Principal Krishnamurthy sir to come on to the dais and honor the Apurva. Now I'd like to invite Ms. Zamuna ma'am and Swati ma'am also. Come on to the dais. So come here.
Yeah, good evening. So finally, first of all, I will give a applause for the Apurva for successfully conducted the FDP program of day one. So thank you, Apurva. So we learned so many things like what is the importance of big data and what are the platforms we have to create by using the big data at the same time. So what is the journey of AWS and this AWS, what are the services we have to use. So all those things today we learned so many things we learned with an real-time examples. So thank you so much, Apurva, once again. Yeah, this is the end of the session. We'll conclude the session and we'll continue tomorrow.
ఇంకో మైక్ అంటే ఇవి ఎవరు సెట్ చేసుకోవాలి ఇవి ఎవరు సెట్ చేయాలి కాదు మేడం మేడం మైక్ లేదు ఇంకోటి మైక్ లేదు ఇంకోటి లేదు ఇంకో